All right, it says we're broadcasting, so that's good. Oh, it's a good thing. Oh my gosh. All right, I'll try to pull this over here. Okay, so we're going to cover, and I can see the end. We're going to do chapter 21, which is going to be a 2-sample t-test, independent. Now, by the way, you remember your outline? This is not on your outline.
Like, you mean the homework?
No, remember the outline that I gave you a few weeks ago with the 7 or 8 steps? Was it 7? I think it was 7. Remember that? This is not on there. Okay? So this is bonus material. Okay? Which will actually, I think, I'm almost wondering if I should give you guys a couple more fun ones so you could do these hypothesis tests.
Yes.
That would be good. Anyway, we'll see. So, by the way, just a quick recap on the schedule here. So we're going to cover chapter 21 today, 22 tomorrow, Thursday. We'll have a review following Tuesday. We'll have a test following Thursday. I may or may not add to your project, and we'll work on your project from here on. We will present in class on the last day, unless you want to present sooner.
Wait, so this is the last test besides our final?
This is your last test. However, you should consider your project like a pre-final, because you're going to use basically all of this stuff that we've learned up to now. I think I might add a couple of things onto your project, but I think it would be good to practice these, and we'll see. So at any rate, so we're going to do a 2-sample t-test that's independent. Yes? I need to see what the schedule is. The written test will definitely be next Thursday. The computer test will depend on when the testing center lets me have it. I will try for Wednesday, Thursday, Friday, and we'll see if I can get that, but I won't know until I schedule it. So, all right. Now, so we need to talk about independence versus dependence. I'm trying to decide if I should teach you the dependent test. I might. Probably not. Independence versus dependence. Okay? Now, typically, dependence deals with paired data. Okay? So it could be the same individual measured twice. It could be like twin studies. By the way, I have to tell you something very interesting. Do any of you listen to podcasts at all? You love which one? You love me some podcasts?
Yeah,
Is that what you
love
said?
me some podcasts.
Oh, I thought you were saying the name.
Oh,
What's
no.
the podcast you like?
The one, it's called How It's Built, but they talk about like how they build their companies and stuff. Like,
How this is built?
Yeah, that one. I love that one. I love all the serial ones, like they do like the murder cases.
Murder cases, yeah.
Yes.
Have you ever listened to Hidden Brain?
What's that?
The Hidden Brain?
I don't know.
It's about psychology kind of stuff. So there's a really interesting study on, since we're talking about twins. So in South America, I want to say Colombia, but I might have the country wrong. A mother gave birth to twin boys, identical twin boys. One of the twins, did you hear it?
I think so.
One of the twins had medical problems, so they shipped him like several hundred miles away to another hospital where another woman had identical twin boys.
Oh no.
The hospital mixed up the twins. And so both mothers brought home twin boys, but they thought they were fraternal twins, not identical twins. Okay? So one grew up in the country, one grew up in the city. One day, this guy's in the butcher shop just doing his job, and this woman thinks that she knows him, and she's like, "Why are you standing behind the butcher shop?" He's like, "This is my job." And she realized that she knew somebody that looked exactly like him. And then they found out that they were swapped at birth.
Oh my gosh.
So wait, just one of them was swapped?
No,
Or
one set of each twin was swapped.
right. One set of.
So it's like there's two, and then they paired them off differently. And
Both the bees got put to the other mom.
Oh no.
So yeah, so one child was raised by the wrong mom in both cases.
Did it say how old they were?
They were in their 20s when they found out.
Dang. The long race, did it say one was wealthier, like the one
Dude,
okay.
You should listen to it. It's really super interesting. But at any rate, so the reason I'm bringing this up, number one, it's super interesting and you should go listen to it. And number two, Hidden Brain also talks a lot about statistics, so it's really interesting that way. But I'm trying to give you an example that twin studies are often dependent. Another case would be something like a husband and wife. You could maybe pair up by a husband and wife and do a study that way. You have a natural pair going on, okay? Or you can do a matched pair. And let me give you an example of a matched pair. I think I might have told you this at the beginning of the semester, if I remember right. Or it might have been a different class, I'm not sure. At any rate, so there was a study done in Somerville, Massachusetts, and there was a priest, and he wanted to cut down on juvenile delinquency. So he wanted to do a study and see if a mentor would help, okay? So let's say Brenda and Kensley are the same age, we're going to pretend, okay? So they're both girls, they're both 15, they both steal stuff, okay? They're both juvenile delinquents, okay? So we're going to give Brenda the mentor, and we're going to give Kensley nothing, okay? I did tell you this story. So who comes back to prison? The one with the mentor. Okay, really weird, okay? So in this case, there was no relationship between Brenda and Kensley. They were just matched based on age, socioeconomic status, and sex, let's say. So you can create your own matches and that sort of a thing. So these are 4 examples of what we would call a dependent study, okay? Now, independents are just going to be 2 independent groups. An example on that might be men versus women, or Republicans versus Democrats, or something like that, okay? So I don't want to give you all these, but it's going to be important for you to be able to distinguish whether a study is independent or dependent, okay? We're going to focus on independent today. I don't know, maybe I should do some dependent stuff. That might be interesting. We might do dependent, we'll see. We might push back the test back if we do that, okay? We got lots of time, so I'm not worried about that. But at any rate, so I want to give you 2 scenarios here, and I want you to tell me whether you think this study is an example of an independence or dependence, okay? So let's say that a researcher wants to determine the effectiveness of a new medication to treat the common cold. Okay? So they randomly put people into 2 groups. Let's pretend I did. We're splitting you down the middle. Group number 1 gets the medicine. Group number 2 gets the placebo. Okay? Is that an example of an independent or a dependent study? Okay, so let's vote here. Okay, 2 groups. 1 group gets the medication, 1 group gets the placebo. Who thinks that is independent? 1. Yeah, don't hurt anybody when you raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who thinks it's dependent? 1, 2. Why do you think it's dependent, Colin?
Because I want to say it's a matched pair, how we're applying the same treatment to two people.
Okay, you think it's a matched pair. What do you think?
I would say match pair as well.
You think it's a matched pair, so we're just splitting up into groups. This group gets the placebo, or the drug, this gets the placebo. You think that's a match?
Well, I would say so because in like clinical trials and stuff like that, they have to get like similar people with like similar, like you all have to, you all have to have certain criteria. Which is why I.
Yeah, we just said we were randomizing this. So this is actually a case of independence. Okay, so now if we were going to randomize it, if we were going to do a dependent, I'd have to pick Brenda and Ashley and pair them together. I didn't say I was pairing them together. I was just putting everybody into a group.
They had no similarities.
Yeah, I wasn't saying they were similar. I wasn't putting men in one group and women in the other or anything like that. Okay, does that make sense? All right, so here's scenario number 2. A professor measures the time for 12 students to catch a falling meter stick using the dominant hand versus the non-dominant hand. Here, I'll try to do this on camera here. So let's pretend that I'm not holding that. This is a meter stick, okay? We're going to compare the dominant hand versus the non-dominant hand, okay? Pretend that was a lot longer than a short thing. So the question is that scenario, who says it's independent? Nobody? Who says it's dependent? Okay, everybody. Why did you say, Brady, that it was dependent?
I looked at it on my paper and I was looking if it was the same individual, if it was a twin study, if it was husband and wife match pair. But it's not a man. I don't know. I just looked at the independent. It doesn't make sense that it's men versus women or Republican versus not like an independent group.
It's not independent. It's dependent because why? It's the same person measured twice. Okay? Let me throw you one more scenario at you. Okay? This is a class project we used to do in one of excuse me, one of my other statistics classes. You go to the store, you buy 2 packages of Oreos. One is regular Oreos, the other is double stuff. And you want to see if the double stuff has twice as much stuff as the regular Oreos. That sounds like a good one. We should do that one, huh? Okay, so who thinks that's independent? One. Who thinks that's dependent? Are you raising your hand twice? Okay, dependent, raise your hands high so I can see. 1, 2, 3, 4. Who didn't raise your hand? You all got it wrong. Okay, you said it was independent because they're just 2 different packages, right? Who said it was dependent? Landon, why do you think it's dependent?
Because we're doing Oreos. It's just like testing the same exact person, dominant versus non-dominant. Oreos, double stuff, not double stuff.
Okay. Brenda was right. It's independent. Okay. Now, let me ask you another question. When we think about Oreos, did you know that double stuff has fewer cookies than regular Oreos?
Yes.
Because I need more double stuff, so.
Well, it's because they can't.
But the double stuff just tastes better.
Because the Oreos have more.
Okay, so if we were going to do this as a dependent test, would it make sense to take cookie 1 out of the double stuff and cookie 1 with the regular and pair those up together? Would that make sense? No. Why? Well, for one thing, they don't have an equal number. What happens when you run out of pairs? Well, that is a good question. What happens when you run out of pairs?
You only do however many.
Or let's back up. Let's pretend we're doing the falling meter stick, okay? We're trying to compare the dominant hand versus the non-dominant hand. What happens when you have a one-armed student? What do you do with that student?
He's excluded from the test.
He's excluded from the test, okay? So yes, so the case of Oreos, you need to listen to Brenda. Brenda was right. That's an independent t-test.
Wait, it's a what?
It's an independent test.
Why?
Because what does Oreo regular have to do with Oreo double stuff?
They're both Oreos.
Well, they're both Oreos, but so what? You two are both men. Does his score depend on what you do?
No, but
You're both men.
exactly, that's both dependent. That's the
The fact that they're both
they're
men makes
both
it
men.
dependent variable.
You just really said you could pair like two the
Similar,
similar
like
things.
a wife and a husband aren't even the same
agree.
gender.
Yeah, somebody go to Walmart.
They're twins, so what? They're different people. Let's go get it.
Okay. So independent one has nothing to do with the other. Oreo double stuff, it's just the randomly, when it comes out of the manufacturer, you just randomly put those into each bag, right? Or each container. Okay. My last class, we just talked about this in my 2040 class, they didn't argue with me near as much as you guys. Okay?
I know, I just want to give us another scenario.
Another scenario? We'll tell you what, we'll do a scenario today and then we'll talk about it. Okay? All right. Oh, I just went out of focus really bad. All right. So, okay, so we're going to focus on the independent test today. Okay? And let me just mention this on the dependent test. You have to have equal numbers for the pairs. Are you guys listening to me? The independent, you do not have to have equal numbers. Okay? So for the dependent, so that's another reason why the Oreos and the double stuff and the regular Oreos, they don't have the same number of cookies, right? Double stuff have fewer cookies. And so in order for it to be dependent, you're either going to have to throw out the cookies that don't match, but you have to have those in equal numbers.
So if you were to compare,
Or you're going to have to exclude the one-armed student from the test.
what if we do 10 double stuffed Oreos and 10 regular Oreos? Is that now dependent?
No, it's independent.
But they're the same amount of numbers.
You can have the same number, you don't have to. In this one, you have to have. Now, everybody's got two arms, right? These arms are my pair. They're my pair. They're a matched pair. Are you and Colin a matched pair? No, you're not. You're a matched pair of wrong answers. Okay? All right. So a husband and wife would be a matched pair. Now here's one more. Let me throw this one at you. Okay, so let's say, for example, you want to find and see if there's a difference in airfare if you buy something a month out versus a week out.
Yes.
Okay? So you pick Southwest Airlines. Did you know that Southwest is flying to Hawaii now? Did you know my wife works for Southwest Airlines?
Yeah.
Guess where we're going this summer? Hawaii.
So that's right, Florida.
So at any rate, okay, so let's say the Salt Lake airfare to Honolulu. Okay? We're going to check that airfare a month out, and we're going to check it out a week out. Is that an independent? Who says that's an independent sample?
I'll be honest.
Nobody? Who says it's a dependent sample? Only 2 people? 3? Only 3 people got that right. The rest of you didn't. Do it again. Now that you know the answer. Okay, you're trying to check airfares a month out and a week out to see if there's a difference in price. Okay, so you check the airfare from Salt Lake to Hawaii to Honolulu a month out and it's $400. You check it out a week out and it's $500. Is that a matched pair or is that Independent. It's the same airline, same cities. What's the difference? The time. A week out versus a month out.
Okay, so it's dependent.
So it's dependent. You've got a match pair. You're pairing the city, two cities, Salt Lake and Honolulu.
Same airline, then it would be independent. Yes.
Yeah, okay, so we could do that with, yeah, so if we were comparing Southwest, a bunch of airfares to a month out to United,
Right.
would that be independent or dependent? That would be independent. Okay?
So how do you
Southwest doesn't have anything to do with United.
like, you just kind of have to play by ear in determining how many variables will make it a matched pair, because they are both airlines too. So that's like a.
Okay, if we were going to figure out Donald Trump supporters in here, we wanted to compare the men versus the women. Okay? Men support versus the women support. Is that independent or is that dependent? Who says it's independent? 1, 2, 3, 4. Who says it's dependent? 4 was correct. Okay? The rest of you all didn't get that answer correct. There's going to be homework questions that say distinguish between independent and dependent. I can tell this is going to be a hard question for you guys. Okay? All right, let's just do. So I'm going to focus on the independence test. Okay? And let's pick one here. So number one, let's talk about the rules. The rules. Number one, they need to be a simple random sample.
This is for independent.
For the independent test. Okay? Number two, they must be independent. Okay, and I can tell you guys are struggling with that. Number three, they must be normally distributed with no outliers. And here I'll use this as number 4. They do not have to be the same numbers, but should be close. And N1 should be greater than or equal to 30. And 2 should also be greater than or equal to 30. Okay? So let's do an example. Go ahead and open up Canvas. And I've hopefully got a spreadsheet here. We'll see. If not, I'll upload it really quick. All right, let me start sharing here. Okay, so if you go to Math 1040, oh, is my screen not on? It's not on, turn on. And then you're going to go to the assignments, go to the bottom, and hopefully we've got in-class worksheets. Oh, I didn't include it. Okay, I'll upload it right now really quick. Let me go to my other class because I know it's in there. Didn't mean to erase that. Camera's taking forever to warm up anyway. Okay, I'm going to upload this. I wonder if I can just drag it. No.
Really?
No,
No, I don't know. It hasn't been like, I
I
know, like my roommate does it, and like I've talked to my sister and my parents about it, and they're like, don't do that. It's like,
Okay, go ahead and refresh your page, and you should have a worksheet now called Worksheet 11.1-11.2. Okay?
Is this other files?
It should be under in-class worksheets. If you go to assignments, go to the very bottom, there should be a thing that says in-class worksheets.
What is, which one is it called?
11.1-11.2. Okay, so here's the scenario. Scientists wanted to know if there was a difference in the red blood cell counts for rats in space versus Earth. They sent 14 rats into space and checked, yes I am, the red blood cell count and compared it to the red blood cell count for 14 Earth rats. Is there a significant difference? Use alpha equals 0.05. Okay? So what's the first question you should ask yourself when you're doing a hypothesis test?
First question, yeah. So, is it? No, that's not the first question. Is it?
That's the second question.
Yeah. First question. First one is, yeah, choose your numbers.
Find the numbers. Okay, I've given you raw data here. What numbers would you want to know?
No.
You probably want to know the mean, right? And how do we find the mean?
Equals average.
Equals average, and then what do we say, Brady? First Bill Gates. What else might you want to know? What do you think? Standard deviation, right? How do we find the standard deviation? ST-dev, right? What else might we want to know? Not yet. How many rats am I using? We want our, 28 total. We got 14 space rats and 14 Earth rats. Okay? Now, since we've spent so much time here, are these independent or dependent, would you say? Should we vote? Who says they're independent? 1, 2. Who says they're dependent? 1, 2, 3, 4, 5. Why do you say they're dependent? Audrey. She slinks
Well, I say
away.
it's dependent because they're all rats.
Because they're all rats. You think everything's dependent, don't you? Why do you think, Audrey?
See, last time I won, so I don't know, but then like, you're testing 14 rats in each place and you're just like testing them, you're testing the exact same things, but just in different locations.
We're testing them in different locations. And because they're in different locations, that makes them dependent?
Everything's the same except the locations. There must be 10. No, it's not. They're independent.
Kensley, why did you say independent?
Because all the rats are different.
I was just, because I guess space versus Earth.
Space versus Earth. If we randomly assigned them, okay, let me back up here. Shh, you gotta be with me here. I'm trying to teach you guys, but you're doing a lot of talking, and that's not helping you learn, okay? Now, if I've randomly assigned them, am I doing any matching?
No.
So therefore, if I'm not doing matching, it would be independent. Okay? Does that help? Did I say that they were matched anyway? No, so therefore they're independent.
Okay.
Is that helpful?
Yeah.
If they're dependent, there's got to be some sort of a match. Okay? All right, so we found the numbers. Step number 2, and we decided it was independent. Step number 2. Categorical or quantitative? Should we vote? Who says it's categorical? 1, 2, 3, 4, 5, 6, 7, 8, 9. Who says it's quantitative? Nobody? Why did Tanner, you pick categorical, didn't you?
I did, yeah.
What are the categories?
Earth rats and space rats.
Okay.
Who would win?
I think space rats.
Those are groups. Category has to be yes, no, true, false.
But we're counting red blood cells, right?
And we're counting red blood cells, which is a big number. Do you remember in chapter 1 when you thought this was so easy?
I never thought this one.
It's quantitative.
Well, I don't know if you know.
Because these are not yes, no numbers. These are actual numbers here, right? Are these... Oh, we should start preparing for the final exam anyway.
Oh, we also.
It's quantitative. You all said categorical. The ones who voted, nobody said quantitative.
I was thinking, like, I was thinking numbers all the way. And I was joking when I said, when I said my joke, did I say quantitative?
We'll have to go back and listen to the tape. All right. You guys are really scared me, not only for your final test, but your final exam, if we can't get these questions right. These should be, I thought you guys were good at this by now. All right, question number 3 is, what kind of a test?
The T test.
Is it a Z, a T, a chi-square? Oh, you don't do the F. Chi-square, he wants to flunk the class.
Yeah, I'm assuming we're doing a 2-sample.
Okay, we're going to vote here. Who thinks it's a Z? Nobody thinks it's a Z? Who thinks it's a T? 1, 2, 3, 4. Who thinks it's a chi-5? Who thinks it's a chi-square? Oh, this is step number 4.
She's the one who came up with that.
You're right. This is. Here, we'll do step 4. I always do step 4 first. Who thinks it's a chi-square? Is that why you were raising your hand? Oh, sorry. I should have called on you. I'm sorry. Okay, so we're going to finish this answer. It's a t-test. Why is it a t-test?
That's the title of chapter 21.
Okay, and when you're not looking at your book, why is this a t-test?
I was going to say, we don't have the population standard deviation.
We don't have the population standard deviation. That's why. It's a t-test, but it's not just any t-test. It's a T2 sample independent test. Okay? Because I forgot it. But we're going to go back to step number 3 right now. What's the null and the alternative hypothesis? I've been skipping step number 3 all day today. I don't know why. So, Lindsay, since you remembered step number 3 better than I did, Lindsay, what is the null and the alternative hypothesis? mu.
Do I have to have, are there gonna be twos or?
There's two means there, aren't there? Well, those are those parameters? No. So it can't be 7.88 and 8.43.
So we're saying equals the same.
You're on the right track though. How about mu1, or we could say, normally I say mu1 equals mu2, but if you want to be super clear, you could say mu space equals mu earth. Okay? Or mu1 equals mu2, or mu space equals mu earth. Okay? Now, Gage, what do you think the alternative hypothesis is? The opposite meaning
So mu space is not equal?
not equal to? Who agrees with Gage? Who disagrees with Gage? Okay, it's unanimous. He's right. Mu space does not equal mu earth. Okay? All right, so now it's two sample T independent. I need to give you a new formula. This is not on your notes for your outline from a few chapters ago because we're covering a couple more things, okay? So let me stop sharing here.
What's that on Canvas all worked out?
This problem we're working on?
Yeah.
Sure. Now let's go over here, okay? So the new formula, the formula of the day is T equals, and we can kind of see that, x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. Okay?
So S2, 1.
S1 squared and S2 squared. That's your formula. Your degrees of freedom are, and I can't remember if I deviate from the book on this, but I think the book goes into way too much detail. Here's what I want you to know on the degrees of freedom. It's the smaller of N1 and N2. Whichever one's smaller, subtract 1. There's actually a really super complicated formula. I don't want you to learn it. I just want you to learn this one. Your degrees of freedom is the smaller of either N1 or N2, whichever one's smaller, subtract 1. Okay? In this example, they're the same, but they'll be different quite a bit. They'll be different more often than not. Okay? Like the Oreos. Okay? I think the Oreos, you guys might actually remember that now, right? Okay? Yes?
So just to confirm the degrees of freedom, we have N1 and N2, whichever one's smaller, we take that one and subtract 1 from it.
That's correct. Okay? All right. Oh, I guess I didn't put that in there. All right. So let's go back here. I can't hear you.
Oh, sorry, I was listening.
All right. So in this case, T equals, who haven't I picked on? Shire, I haven't picked on you today. Can you help me punch these numbers through?
Equals 7.8807.
7.88 minus 8.43. So we're calling this 1 and 2. That makes sense, okay? That's your numerator. Your denominator equals
The standard deviation, so it's 1.8.
how about the square root first? You do the square root first, right? Square root. Oh, am I sharing this? I'm not sharing. We need to share this. Hurry and share. Not responding. Oh, please don't tell me this just crashed. Okay, well, you're going to have to take really good notes because I don't know what's going on here. Okay, the square root of, I don't know if this is sharing, so 1.01 raised to the second power divided by 14. Sorry, let's try that again. Okay, plus
1.005
raised to the second power, also divided by 14. Okay, so that's going to be my numerator divided by my denominator, which gives me negative 1.43. This is still frozen. I don't know what to do about that. I do have another video that goes over this same one that I did a year or two ago. We'll try to do that. Okay? Hopefully it recorded the beginning when we were talking about independence and dependence. Okay, so now what? What's the next step? Kensley? Find the p-value. And how would I do that?